Hello chemistry fans, and welcome back to Chemistry 1032 problem solving session here at the Academic Success Center on Broward College North Campus. I am your host, Dr. Russell Betts, and I will be leading you through these problems today. So let's take a look. Complete the following table with the formula and name of the compound that forms between each pair of ions. Alright, so we have some cations on the left here and some anions running along the top. And we want to make formulas, and we want to name the compounds. Okay, so let's make the formulas first, and then we'll go back and we'll name them. So, we have lithium plus 1 and chloride minus 1. First thing we have to know, the formulas must be neutral. That means the pluses must equal the minuses. That's how we have to do it. So let's write down Li plus Cl negative 1. Here we have one positive charge and one negative charge. So the charges are already equal, they're already balanced, so we don't have to add any more lithiums or any more chlorides, So the formula here is LiCl, because the charges were already balanced. All right, over here, now we have Li plus 1 and O negative 2. Okay, now we have a problem. The positives and the negatives do not equal. We have to have two positive charges and two negative charges. And the only way to do that is to add another lithium. So there has to be two lithiums in this formula. There can't just be one. If there's only one, the formula would not be in balance. So there must be two lithiums, that's a total of plus 2, one oxide for a total of negative 2. So the ratio would have to be Li 2O, and I subscript the 2. Li subscripted 2 means there's two lithiums in this formula and one oxide. Remember, the rule is hard and fast. The formulas must be neutral. They must have no charge. So the negatives and the positives must equal. So now, lithium plus 1, nitride negative 3. All right. So now we have minus 3 here, plus 1. So the negatives and the positives are not equal at this point. There's too many negatives. So let's add a couple of more positives. There's Li, another Li, so we have two lithiums now, plus 1, plus 2, so a total of positive 2 for the cations. Still not enough. Li plus again, a total of plus 3 for the lithium. So we have to have 3 lithium cations to counter the N minus 3. So now, in the formula, the ratio would be Li 3, 1, 2, 3, N. There's only one N, the 1 is assumed. You don't have to write the 1 in. So that's how you would do that. Now, for the next two, I'm going to show you a little bit of a shortcut called the Crisscross Method. I hesitate to show that to students because you have to be very careful with it. You can't just accept what it gives you at face value. You have to always scrutinize it and reevaluate it to make sure that it's right. And I'll show you why here in a minute. But for now, let's just try it. So we have calcium, Ca, plus 1, chloride minus 1. Now the crisscross trick, let me grab another color here. The crisscross trick says simply take the absolute value or the numerical value from the subscript and crisscross it like this. So that number here is going to go here, and that number here is going to go there. That's what the crisscross trick says to do. This 2 will come over here to the chlorine, subscripted. This 1 will come over here to the calcium, subscripted. So it will be in the charges, the plus and the minus, just drop those away, just ignore them. So now it's going to be Ca1, Cl2, or CaCl2. Sorry for the crampness there. The 1 is assumed, so it becomes Ca, drop off the 1, Cl2. All right. Calcium, Ca plus 2, O minus 2. Let's do the crisscross trick again. Here you have to be careful. 2 and 2. So the 2's drop down, giving us Ca2O2. Now, notice these two numbers are the same. So basically what I want you to think about is I can divide evenly into both numbers. 2 divided by 2 is 1. 2 divided by 2 is 1. So the ratio here is actually CaO. This is the correct answer. Okay? Ca2O2 is not correct. You can reduce that down to CaO. Think of it as a ratio. 2 to 2 is the same as saying 1 to 1. Okay? So it's CaO. All right, onward and upward. Ca plus 2, n minus 3. Crisscross trick works very well here. So the 2 will come down to here, and the 3 will go over to there. So the final answer will be Ca3n2. I just took the numbers and moved them, subscripted them, crisscrossing it through the molecule. All right. Next one. Al plus 3, chlorine minus 1. Again, we can simply crisscross this. And that will become AlCl3. Very good. Okay, here's the next one. Al plus 3, O minus 2. Again, with the crisscross trick. This one will be Al2O3. And the last one in our list, Al plus 3, N minus 3. Final crisscross trick. Now notice they're both 3, so it's going to become Al3N3, or just simply ALN. Okay? And that is how you write the formulas. Now, to write the names, I'm going to actually just grab the same question. This is exactly the same question, but now it's just a clean sheet. It's just a clean sheet, because this one's getting a little busy. I'm just going to grab a clean sheet of paper and do the problem now just with the naming. So here, we made the formulas, and now here, I'm going to do the naming. Also grab, if you will, your periodic table, in case you need to know the names or the correct spelling of an element or an ion. Okay, so this was lithium chloride, or LiCl. Now, when naming a ionic compound, the cation is always simply named the cation. So, for example, lithium, if we look at the periodic table, lithium, its name is lithium. It's a cation, so its name will not change. The name will not change in the naming of a compound. So the cation's name will stay the same. So here, it will be lithium. Now, the Cl is chlorine. Over here, chlorine. I know you're tempted to say it's lithium chlorine, but you don't. The INE changes to IDE, the suffix of the word. So instead of saying chlorine, it's chloride. Here it is. Let me change color. Chloride, I-D-E. The anion will change its name. The cation, its name will stay the same. So lithium is lithium on the periodic table. It's lithium when you're naming the compound. It's the anion that changes names. All right, next one. Li2O. Now, students will always have a hard time with this. They always want to say dilithium. You never say di, tri, mono, tetra, any of that stuff in ionic compounds. These are ionic. They're cations and anions. Never say di, tri, tetra, mono, penta, any of that stuff with ionic compounds. A cation and an anion. It does not require di, tri, tetra. This is simply lithium oxide. O-X-I-D-E. I-D-E. Not oxygen. oxide. All right, moving on. The next one is Li3N. Again, name the cation as the cation. Lithium. Now this is nitrogen, but it's not nitrogen in a formula. It's nitride. Okay? Again, IDE. Okay? Next column. Calcium plus 2 and chloride. So that's going to be CaCl2. This is calcium, so it's calcium chloride. It is not calcium dichloride. Don't say that. This is ionic. Here we have a metal and a nonmetal, a cation and an anion. Calcium chloride. You don't say dichloride. Don't say that. Next on our list is CaO. This is calcium. The cation stays the same. The name doesn't change. Oxide. Again, IDE. This one, Ca3N2, is calcium nitride. It's not tricalcium dinitride or dinitrogen. Don't say that silliness. This is an ionic compound. Calcium is a metal, so it can only be a neutral or a cation. This is calcium nitride. This is ionic. Okay? All right, next. AlCl3. This is aluminum chloride. Aluminum chloride. Aluminum is the cation, so its name doesn't change from the periodic table. This is chlorine, so then it becomes chloride. IDE. The next one, Al2O3. That is aluminum oxide. Aluminum oxide. Again, the cation stays the same. The name doesn't change from the periodic table. Oxygen is called oxide because it's an anion in an ionic formula. So it's called oxide. Do not say, because this is ionic, do not say dialuminum trioxide. That would be incorrect. This is ionic. It doesn't require that nomenclature. Okay. And the last one on our list. This will be AlN. That will be aluminum nitride. Do not say monoaluminum nitrogen or aluminum mononitrogen. Don't say any of that stuff. This is aluminum nitride. All right? So, I hope this video has been very helpful to you. I hope that you were able to go through this problem and get all the answers right. If you still have any problems, please contact one of the many tutors here at the Academic Success Center or come on by your professor's office hours for additional assistance. I sincerely hope that you've got this squared away and you're able to do it on your own. If not, please seek help. It's really not that hard to do once you get the hang of it. And I'd like to bid you good luck and good chemistry.